Are you ready? Let's do another one. Okay, so I got to determine points of inflection and discuss concavity. That's going to require second derivative. Before I start, I should list out what my domain is. So do I have any no-no numbers? So my domain is all reals. That's good. I won't have any issues when I graph the original function. It's just going to be a beautiful quartic. Okay, so get me to second derivative all by yourself. Kind of too easy, wasn't it? I'm sorry for insulting you. Okay, so of course, if I'm going to figure out points of inflection and look at concavity, I need to check where is it equal to 0 and where is it equal to undefined. Of course, this particular second derivative won't be undefined because it's still a quadratic, and quadratics are defined everywhere. But I can figure out where it's equal to 0, and of course I'll be able to factor out, and I'm going to get two answers, x equals 0 and x equals 2, so I have two possible points of inflection. So I'm going to make a table so I can test them. So notice in this one I didn't put x equals 0 and x equals 2 in it. I don't have anything strange going on with the shape of f of x, so I didn't need a place to write in vertical asymptotes. Okay, so I'm going to do some testing. In this first zone, I think I'll test -1. In this second zone, I'll test +1. And at this last zone, I'll test +3. Remember, we are plugging into second derivative. So I got a positive when I plugged in -1. I got a negative when I plugged in +1. And I got a positive when I plugged in +3. So here it's positive, so it'll be concave up. Here it's negative, so it'll be concave down. And in the last one it's positive, so it'll be concave up again. Which means I get some really pretty points of inflection where it's changing concavity. So I'll have a POI at x equals 0 and at x equals 2. And now, woo! I almost got sick there for a second. If I want to find the actual points, of course, I can plug back into the original, always the original to get y values. If I plug 0 back into the original, I'll get 0. And if I plug 2 back into the original, I'll get 16 minus 32, which is -16. And there are my 2 points of inflection, and I've also discussed all the concavity. So I love these puzzle ones. So I start by paying attention to what it is they're giving me. Like here, I go, oh, those are y values, because those are f of x values. So I know the y value is 0 when x is 0 and when x is 2. Ooh, I love this. And then I don't see any more y values anywhere. So next I'm moving on to, ooh, slope. So the slope is positive when x is less than 1. So less than 1, I should be going up. And then the slope is 0 when I'm at 1. Oh, I'm going to get a turnaround point. So I'm going to turn around right there, right? Because if I draw in the tangent line, it would be horizontal. And then my slope is negative when I'm greater than 1. So now I got to be headed back down. And then I notice, oh, the second derivative is negative, and if the second derivative is negative, can't say that so well, it's concave down. So I get to finish this. Ooh, I have to make sure I hit 2. There's one possibility. One possibility. So keep in mind that I don't know how high this thing goes up. It could have done this and then turned around. Or maybe it's a little shallower and it did this and it turned around. So all sorts of possibilities, but all of those fit the puzzle pieces.